So we're going to talk a little bit about titration now and the different types of titration that you need to be aware of in terms of acids and bases, okay? So obviously the topic's called volumetric analysis. Now the things you need to know here, girls, what the term concentration actually means, how to express solution concentration in different ways, so your weight per weight, these are the percentage values, weight per volume, volume per volume, parts per million, and moles. We've just done moles, so we're not going to focus too much on moles in this video. How to do titration calculations using the correct formula. So the formula that VA by MA all over NA, okay, is equal to, you know the one I mean. The glassware needed for titrations and how we treat them, what a primary standard is, what a standard solution is, and the little kind of key features to look out for when you're practicing these titration calculations. So what the term concentration means. So concentration of a solution is how much solute is dissolved in the solvent. Okay, so obviously, in terms of, the little picture shown below, the darker the solution, the more solute's present. Obviously, we can't tell that with acids and bases in the lab because most of them are clear. Okay, so we have to have another way of calculating their concentration. So we do a process called titration. So first of all, in this chapter, girls, we talk about the different ways you can express solution concentrations, okay? Now, this obviously depends on the type of material you're talking about. So if you're talking about an environmental value, for example, the amount of pollutant in a lake or a pollutant in an air, you'd always use the ppm to do that. Remember, 1 part per million is the same as 1 milligram per litre, okay? So we'll practice some of those now in a second. And your percentage weight per volumes and weight per weights, girls, that usually we were aware of that with alcoholic beverages and stuff like that. Will have a percentage on them. When you're talking about that, it's percentage volume per volume, okay? And when we do the vinegar titration, we look at your percentage weight per volume as well, okay? So remember, for all of your percentage weight per weights and weight per volumes, girls, it's always out of 100. So if it's W per W is weight per weight, so it's going to be the number of grams in 100 grams of solvent, okay? If it's going to be weight per volume, it's going to be the amount of grams per 100 centimeters cubed of solvent, okay? If it's going to be volume per volume, it's going to be the number of centimeters cubed per 100 centimeters cubed of solvent. And remember, parts per million is the same thing as milligrams per litre, or milligrams per 1,000 centimeters cubed. And then obviously moles we've looked at already. Now, I'm going to ask you to pause this video for a second and give these a go. See if you can remember how to work these 4 concentration calculations out yourselves, and I will follow this with a little demonstration on how to do it. Hi ladies, so I'm going to talk you through some of the concentration questions. So first one, we're looking at trying to calculate your percentage WW, which is weight per weight. Remember, you're trying to work out how many grams are in 100 grams of something, okay? So you've got 2 kilograms of salt water, okay, that's 2,000 grams, okay? 200 grams of salt after evaporation. So all you're doing is you are dividing by a factor of 20 to work out how much was in 100 grams. So it's 10 grams in 100 grams of water, therefore it's 10% WW, weight per weight, okay? Vodka, we're saying it's 78% volume per volume, okay? So that means there's 78 centimeters cubed in 100 centimeters cubed of vodka. So therefore, to work out how much is in a litre, you just multiply by 10, because remember, a litre is the same as 1,000 centimeters cubed. So it's 780 centimeters cubed in 1,000 centimeters cubed of vodka, okay? Then your ppm question. Now the thing about ppm questions, girls, is you just always have to remember that 1 ppm is the same thing as 1 milligram per litre, and that a milligram is 0.001 grams, okay? So you've got 0.0003 grams in 100 centimeters cubed. Okay, we're going to have to work out, first of all, the milligrams, and we're going to have to convert that to 1,000 centimeters cubed or a litre, okay? So therefore you are going to say that 0.0003 grams, multiply that by 1,000 to get the milligrams, so it's 0.3 milligrams in 100 centimeters cubed, and then you simply multiply that by 10 to be able to work out how much was in a litre. So your answer there is 3 ppm, okay? Your final question, part 4, So for this one, you are looking at moles. So we've already done moles already. So it's 1 gram of NaOH in 1 litre. Remember, molarity is how many moles are in a litre. So it's already in a litre, so we don't need to change that. That's good, okay? So we just need to have to work out how many moles are in 1 gram. So what we're going to have to do is go back to your mass moles triangle, and you're going to have to work out the mass divided by the weight of sodium hydroxide, which is 40. So your answer is 0.025 moles per litre.